learn about the Bragg's law, and it is a very important topic from the solid state chemistry, not just because from the examination point of view, but as a general it is a very important topic. Maybe when you will pursue the PhD you will need the deep understanding of this Bragg's law, because in the XRD for your characterization of the sample you should have a good amount of knowledge about this Bragg's law. Fine. Anyways, this is not something which we are going to talk in the video. So the Bragg's law is say that the Bragg's law say that the path difference is an integral multiple of wavelength. Fine. Let's say we have a crystal structure and we have passed the X-ray, then the path difference will be an integral multiple of wavelength, which we write it as 2d sine theta equals to n lambda. So from where this expression came, so let me derive. It's a very small derivation, so I won't take much of a time. Let's say we have a one plane, equidistant planes. Alright, so when we pass this rays, it will be reflected. Fine. Let's say I take another. Let's say I pass a normal and I take one more ray and it will be again refracted. So this is a theta angle of incidence and this is theta. Fine, this is angle of refraction. So what happens, this is refracting angle, this is angle of incidence. So these two angles are equal. So the thing is, let's say I pass a normal here and one normal here. So what will happen, this is also theta and this is also a theta, and let's say this interplanar distance is d. This is a interplanar distance. So what will happen, this is the path difference. Fine, let's say this is A, this is B, this is C, and this is O. So in triangle OAB, I am writing in triangle OAB, what we can write is sine theta equals to perpendicular upon hypotenuse. So this is AB equal upon this OB. So it will become sine theta equals to this AB divided by this OB. OB is nothing but D. That means AB equals to D sine theta. Fine. Now similarly, if you see in triangle this OBC, I can write it as sine theta equals to this BC upon this OB. Fine, which is your D. So this BC equals to D sine theta. Are you getting my point? So path difference is how much? Path difference equals to, this is AB plus BC. AB plus BC. So it becomes D sine theta plus D sine theta, which equals to 2D sine theta. Fine. And in the Bragg's law, I told you that the path difference is an integral multiple of wavelength. So we can write it as 2D sine theta equals to n lambda. This is the final expression. It is an integral multiple of wavelength. So where D is the interplanar distance of spacing. This is the order of reflection. Fine, this is your wavelength. Okay, and this is Bragg's angle. So let's do some problems related with this Bragg's law. So the first problem is very easy, and before this let me take another. So this is the first problem. This came in GATE 2008. And see the condition for observing diffraction from nickel surfaces. This is the criteria for the Bragg's reflection. So what happens that 2d sine theta equals to how much? N lambda. So I am taking for the first order. So it will become lambda n equals to 1. So the thing is, now you can see that this sine theta is equals to lambda upon 2d. Fine, this 2d comes in the denominator, and we know that sine theta, the maximum value of sine theta is 1. For sine 90 equals to 1. Maximum value for sine theta is 1 at 90 degree. It cannot have a value greater than 1. So the sine theta is less than or equals to 1. Fine. That means this lambda upon 2d is less than or equal to 1. So lambda is less than or equal to 2d. Fine. This is the condition for your Bragg's equation. So lambda is less than or equals to 2d. So B is the correct answer. Now see, this question came in December 2015 for 4 marks. And in the question we have a simple cubic structure and a XRD pattern show intense reflection for angles theta 1 and theta 2. That means there are two Bragg's equation which are assigned to 101 and 111. These are HKL values. Fine. These are HKL values. So the ratio of sine theta 1 upon sine theta 2. So write 2d1 sine theta 1 equals to n lambda. Fine. Divided by, for another you can write 2d2 sine theta 2 equals to n lambda, because wavelength will remain same for both, but the interplanar distance will be different because we have different HKL values, and similarly theta and theta 2 will be different. So if you divide, this n lambda cancels out by this n lambda. Fine. That means we have this 2 cancels by this 2. So we have sine theta 1 upon sine theta 2 equals to d2 upon d1. Very simple. And we know that the value of d is how much? We all know that d equals to, for cubic structure, this is a upon root h square plus k square plus l square. So I am writing here, see, we have sine theta 1 upon sine theta 2 equals to a upon, this is root, for this d2 we have this value 111. So right here this is 1 square plus 1 square plus 1 square. Fine. And this is divided by, again we have for this sine theta 2, so we have this d1. So again d1 is a upon root, this is HKL value 1 square plus 0 square plus 1 square. So it will become a upon, this is root 3, and into this will be reciprocated. So it is, this is root 2 divided by a. So a cancels by this a. So we have root 2 upon root 3, which is here nothing but 0.82. Fine. So the answer is in the option, this C is the correct answer. So let me take one more question. Again it is a very easy question. So the question says a plane of spacing d shows first order Bragg. This is a first order, that means n equals to 1 diffraction at angle theta. So write 2d sine theta equals to lambda, because the n equals to 1. Fine. Now it says that a plane of spacing 2d shows Bragg diffraction at which angle. Now we have spacing 2d instead of this d. So first of all let me write what will be the value of sine theta from here. So the sine theta equals to how much? It will become, this is lambda upon 2d. Fine. Or I would say, let me calculate for the d. the d value will be here, so I am cancelling it out. So the d value will be lambda upon 2 sine theta, because the answer is coming in theta, so I have calculated d. So d equals to lambda upon 2 sine theta. Now this is equation first. Now for the spacing 2d, I am writing this is 2d. Now we have 2d. Instead of d, we have 2d. So this is 2 into 2d sine theta equals to, again this is lambda. So what happens? This is 4d sine theta equals to lambda. So what will be the sine theta? This sine theta equals to lambda upon 4d. Fine. So from the first equation, from equation first, we can write this sine theta equals to lambda upon 4. See, this from first equation, this is lambda upon 2 sine theta. So write, this is lambda upon 2 sine theta. So this is 2 to the 4 and this lambda cancels out. That means we have sine theta equals to, this is how much? This is sine theta divided by 2. Fine. That means this theta equals to sine inverse sine theta by 2. So this is the required relation. So option C is the correct answer. So this was very easy. So don't get confused between these equations. These are very easy. Take your time and solve stepwise. So for the next time, thank you and please subscribe to my channel and bye.